This is lesson 5-2, adding and subtracting fractions. Sean surveyed 10 classmates to find which abbreviation they use most when they instant message. What fraction uses L8R? From our table, we can see that 5 students use L8R. When we add the total number of students surveyed together, we find that there are 10. So 5 out of 10 students used L8R. BRB, from the table again, we can see that 2 students used BRB. That would mean 2 of the total of 10 students used BRB. And then question number 2 says what fraction uses either L8R or BRB. We would simply add these two together, add the numerators, keep the denominators. 7/10 of the students surveyed use L8R or BRB. To add or subtract like fractions, add or subtract the numerators and write the result over the denominator. The first example they use here is the one we just did in our getting ready for the lesson segment. 5/10 plus 2/10 is 5 plus 2 over 10 or 7/10. Algebraically, A over C plus B over C means both fractions have the same denominator. We add numerators A plus B, use C as our denominator. Again, it reminds us that we can't have a denominator of 0. In our second example involving subtraction, we have 11/12 minus 4/12, which equals 11 minus 4, or 7, over our denominator of 12. A over C minus B over C, again common denominator, or like denominator. The result then is A minus B over the denominator of C, and again, the denominator cannot be 0. Add 5/9 and 2/9. Write your answer in simplest form. 5/9 plus 2/9. These are fractions with like denominators. We add the numerators. 5 plus 2 is 7. Write that sum over the denominator. You can see that written in the model here, or shown in the model. 5 out of the 9 squares are shaded blue. 2 out of the 9 are shaded yellow. 5 plus 2 is 7/9, which happens to be in simplest form. In our second example, we have 9 out of the 10 blue squares shaded. Represents the fraction 9/10. We subtract 1 of those squares by crossing it out. That represents 1/10. 9/10 minus 1/10. Subtract numerators. 9 minus 1 over the denominator of 10 gives us a result of 8 over 10. 8 and 10 both have 2 is a common factor, so we would divide them both by that. Write an equivalent fraction then of 4/5, which is 8/10 in simplest form. Simplest form, you'll recall from our last chapter, means the numerator and denominator have no common factors other than 1. In example A, 1/6 plus 3/6 gives us 1 plus 3. Adding numerators, keeping the denominator, 1 plus 3 is 4 over 6. Both numbers have 2 as a common factor. Our result then in simplest form is 2/3. Example B, 3/7 minus 1/7 gives us 3 minus 1 over 7. 3 minus 1 is 2. Keep the denominator of 7. 2 and 7 are both prime numbers, which means they have no common factors other than 1. To add or subtract unlike fractions, or fractions with different denominators, we would rename the fractions using their lowest common denominator or least common denominator. What that means is we are making the fractions into different sized pieces. In example 3, add 1/2 plus 1/6. You can see that 1/2 is equivalent to 3/6. You can show that in the model. The blue shaded area represents 1/2. The tan shaded area beneath that shows the rewriting of that fraction or renaming of that fraction to an equivalent fraction of 3/6. The green fraction is 1/6. We add the two together. 3 plus 1 is 4. Over the denominator of 6, we simplify that to 2/3 because 4 and 6 have a common factor of 2. Now, what they did over here, I really like, and this is something we should encourage students to do. When we go back to our original fraction, what they did is they estimated the sum. 1/2 we would leave as 1/2. Remember in lesson 5.1 we rounded fractions to the nearest, to either 0, 1/2, or 1. 1/2 we wouldn't need to round. 1/6 is closer to 0 than it is to 1/2, so we round that to 0. Our estimate then is 1/2. When we check the reasonableness of our answer, 2/3 and 1/2 then are very close, so 2/3 is a reasonable answer. Method number 2, the least common denominator of 1/2 and 1/6 is 6. So using multiplication, we rewrite 1/2 as 3/6 by multiplying numerator and denominator by the same factor, which in this case is 3. 6, we don't need to do anything to that because it's already got a denominator of 6. We then can add the numerators. 3 plus 1 is 4. 4 as a numerator, 6 as a denominator simplifies to 2/3 again by dividing by that common factor of 2. Our estimate here again would be 1/2. Is 1/2 a reasonable estimate for our actual sum of 2/3? Yes, we believe that it is. Example 4, subtract 11/12 minus 3/8, right in simplest form. We're going to round 11/12 to 1, 3/8 to 1/2, so our estimate is about 1/2. Since 12 is 2 squared times 3 and 8 is 2 cubed, the LCM is 2 to the third, or 2 cubed, times 3, which gives us a least common denominator of 24. We then rewrite 11/12 to 22 over 24 by multiplying numerator and denominator by 2. We change 3/8 to 24 by multiplying numerator and denominator by 3. Our resulting equivalent fraction then is 9/24. So now, instead of subtracting 11/12 minus 3/8, we are doing 22/24 minus 9/24, which gives us an answer of 11/24. Remember, our estimate was 1/2. This is very close. Example C. We've chosen to do that one with a model. You can see in the red I have modeled 8/9. I'm trying to subtract 2/3 from that. I cannot do that because I have unlike fractions, which means I have fractions with different denominators. What I've done is I've gone down here and changed 2/3 to 6/9. What I realize is that the least common denominator of 3 and 9 is 9. So I know I can change my thirds to ninths, and I've done that here. Now I can replace my 2/3 with 6/9. My resulting answer then is 2/9. In example D, 5/6 minus 3/8. My estimate again would be 1 minus 1/2, or 1/2. 6 is 2 times 3. 8 is 2 to the third. So my least common denominator is 2 to the third times 3, which is again 24, like we had before. 5/6 becomes 20/24, multiplying by 4. 3/8 becomes 9/24. So my subtraction here, my difference, is 20/24 minus 9/24, which is 11/24, which is again very close to my estimate, therefore a reasonable answer. In example E, 7/8. minus 3/4. I'm going to round 7/8 to 1. I'm going to round 3/4 down to 1/2. So I'm again looking for an estimate of 1/2. I rounded 7/8 up, I round 3/4 down. 3/4 is as close to 1/2 as it is to 1, so I kind of had a choice there. My least common denominator of 7 and 8 is actually 8, so I don't need to rewrite my 7/8. My 3/4 becomes 6/8. 7/8 minus 6/8 is 1/8. A little less than my estimate here. May have been a better estimate to do 1 minus 1, round both 7/8 and 3/4 to 1, which would give me an estimate of 0, which does not mean I expect an answer of 0, but I should expect a really small fraction, which is in fact what I got. In a recent survey, students were asked what they would choose for a healthy lunch. The results are shown in the graph. What fraction more of the students chose salad bar rather than a deli sandwich? Well, salad bar we can see is right here. 9/20, our deli sandwich is 3/25. So our least common denominator, you can see here from the example, is 100. 9/20 becomes 45/100. 3/25 becomes 12/100. 45 minus 12 is 33. My answer then is 33/100, which is already in simplest form. What fraction of the students chose pizza or chicken nuggets? Pizza, I can see from here, is 3/20. My chicken nuggets is 1/10, which means I have to rewrite my 1/10 to 2/20, like so. My least common denominator being 20. I'm adding them now because it says or. So 3/10 plus 1/10, or 3/20 plus 1/10 becomes 3/20 plus 2/20, which is 5/20. When I add the numerators, keep the denominator. 5 and 20 both have 5 as a common factor. So my resulting simplest form fraction is 1/4. What fraction more of the students chose a deli sandwich rather than a burger or fries? A deli sandwich again was 3/25. Burger and fries was 1/10. So I'm going to subtract there. 25 is 5 squared. 10 is 2 times 5. So my least common denominator is 2 times 5 squared, which is 50. So I would rewrite these two fractions. 3/25 becomes 6/50. 1/10 becomes 5/50. My result then is 1/50. Add or subtract, right in simplest form. Number 1. 4/9 plus 2/9 becomes 6/9. Divide numerator and denominator by 3. Answer 2/3 in simplest form. Number 2. 5/6 plus 4/9. 6 is 2 times 3. 9 is 3 squared. Least common denominator, 3 squared times 2, which is 18. So 5/6 becomes 10/18, or actually 15/18, because I got to multiply by 3. 15/18. 4/9 becomes 8/18. Again, I'm adding 23/18, which becomes 1 and 5/18. Example 3. 3/8 minus 1/8. Already have common denominator. Subtract numerators. 2/8, common factor of 2. 2/8 becomes 1/4. Divide by 2, divide by 2. Number 4, 4/5 minus 2/5. 4 minus 2 is 2. Keep the denominator of 5. Answer already in simplest form. Number 5, 1/6 plus 3/8. 6 is 2 times 3. 8 is 2 cubed. So 2 cubed times 3, 8 times 3 is 24. 1/6 becomes 4 24ths. 3/8 becomes 9 24ths. Multiplying by 3 and by 3, by 4 and by 4 up here, in case you aren't aware. Add the numerators, 13. Denominator 24 stays the same. On to the next page to get some more room. We're down to number 6 now. 2/3 plus 5/6. Common denominator is 6, already here, so 2/3 becomes 4/6 plus 5/6 gives us 9/6, which we would simplify to 3/2, which we then rewrite as a mixed number of 1.5. Number 7, 5/6 minus 7/12. 5/6 minus 7/12. Common denominator again is 12. It's already here. 5/6 becomes 10/12 minus 7/12. The result then is 5/12, which is already in simplest form, because 5 is a prime number and has only 1 and 5 as factors. On number 8, 3/4 minus 1/3. 3 is a prime, so I have to multiply it times 4 to get my least common denominator, makes 12. 3/4 becomes 9/12. Minus 4/12, which is what 1/3 is, rewritten as an equivalent fraction with a denominator of 12. 9 minus 4 is 5/12. Same answer as I got for the last problem. Number 9, Cassandra cuts 5/16 of an inch off the top of a photo and 3/8 inch off the bottom. How much smaller is the total height of the photo now? So they're asking me to write those or add those together. 5/16 plus 3/8. My common denominator is 16. It's already here. It's 2 to the 4th, and 8 is 2 to the 3rd. So 5/16 stays the same. 3/8 becomes 6/16. Add them together and I have 11/16, which is the answer to problem number 9. Number 10. The bucket was 7/8 full with soapy water. After washing the car, the bucket was only 1/4 full. What part of the water was used? 7/8 minus 1/4. 8 is 2 to the 3rd, 4 is 2 to the 2nd, so my common denominator would be 8. So I leave 7/8 as it is. I change 1/4 to 2/8. 7 minus 2 is 5. My result is 5/8, which is the part of the water that was used to wash the car. The vocabulary in lesson is like fractions, fractions that have the same denominator, and unlike fractions, which are fractions that have different denominators. At this point, you should quit the video, go back to my Moodle page, log in, go to Lesson Quiz 5.2.